fairly recently, someone pointed me to a listing on Banggood. I can't remember who it was, I'm sorry about that. But it was for these lights, and it's one of a series that's available in the power ratings 12, 16, 20 and 24 watt. And what you actually get is a common power supply with magnets in the back and screw fixings, and you get these strips of LEDs, and depending on the power rating, it can be, hold on, where's the other one? It can be a little short 3 LED strip, or 4 or 5, or in this case this is the highest power rating, it's 6 LEDs. And what you do is this: they come in a scored aluminium panel, and you snap that apart. I wonder why there's a hole there. I wonder if that's a alignment hole for when they're actually manufacturing them. So you snap them apart like this, and then you stuff them into here. There's a circuit board inside, and you sort of angle them in, and I'd actually recommend not pushing them all the way in initially, but just gently put them in at a slight angle. But there's a line on it, a black line, that you have to push it all the way home for the proper operation. So I'll just sit these in, and the reason I suggest not putting them all in hard initially is because it levers the little circuit board up inside, and it makes it a wee bit hard at the other side. So we have it. These are aluminium panels with the shim of fiberglass and then the printed circuit board material on the top, and they've got 2 connection studs which are just basically pads with solder on them. So here's the last couple going in, and then I'll push them all home fully. So that's fully home, that's fully home, and it looks really stylish. It just creates this big star of LEDs. Now I'm guessing these are designed to be used in fixtures, like, you know, bulkhead lights on your ceiling, where you take out an existing, say, a 2D style lamp, and you stick this in either magnetically and connect it in, or probably would be better actually putting the screws in to hold it in. But let's power this up now. So let's crack out the quick test. And once you've put it together, keep in mind this came in a box this size, but now it's basically made a light that is, where's the measuring tape? It's made a light which is approximately 12 inches, 300mm diameter. And let's get the power meter into this as well. That would be good. Kill 2 birds with 1 stone. So let's close this down and plug it in. So that lights up nice and brightly. And the power, this is supposed to be 24 watts, it says 14.4 watts, 14.5, which is a bit naughty, but that's okay. I'd rather things like this were underrun anyway. And the current it's showing is 105 milliamps. Now let's actually measure the current through these LEDs, because I know that all these LEDs are in series. So if I bridge one of the LEDs out with a meter, I'll set this to 200 milliamps DC, and I'll bridge one of the LEDs out. Can you even see anything with this light? Because it's really quite dazzling. I'll shift it along out the way. Being careful not to touch it, which we'll go into in a moment. But you can already guess what I'm going to say from the fact I've just said that. So let's bridge one of these LEDs out, and it says, oh, let's put it to DC amps. That'd be really good. DC milliamps. That'd be a much better result. And we're getting about 86. Yeah, 86 milliamps. Rightio. So noting that it's about 86 milliamps, the voltage across each LED will be roughly 3 volts. Let's put this round to voltage. The voltage across each LED will be roughly 3 volts. Yep, what's the voltage across each entire string? I can do that from these pads here. About 19 volts. Was that 86 milliamps? So hold on. 19 volts times 8 sections times 86 milliamps, was it? 0.086. Oh, that was so wrong. Let's try that again. 19 volts times 8. So the combined voltage across these is 152 volts times 0.086. That's better. 13 watts, which this one, it came to, let's remind myself, 14 watts. So yeah, close enough. It's within a watt. And this looks great. I mean, it's the sort of thing you'd think that would just look great screwed onto a wall, wouldn't it? But here's the snag. There's quite a high voltage across these, and I've already tested, and it's referenced directly to the mains. So I'm thinking it's either a capacitive dropper. It's probably not going to be a capacitive dropper. It's probably going to be a buck regulator of sorts in here to limit the current like that. So yeah, so let's explore this further. Let's open it up. Oh, I should also mention that because all the LEDs are effectively in series, let's see if I can get a zing off this. Is it particularly warm? It's not super warm. Because they're in series, you can theoretically, I've not tried this yet, but you could theoretically just stuff one of these short ones in. How's that going to go? Yep, so I think you could just mix and match these. That opens up possibilities. But let's get everything out of the way here, and we'll open it up and see what's inside and what sort of circuitry it is and what the assembly is like inside. So I'm going to start by pulling all these stems out. I do like this modular assembly. It works quite well. It's just a shame they appear to be live at mains voltage. So really this would be best mounted inside a existing fixture, but if you consider if you've got maybe an existing ceiling light, you know, one of the big huge round ones, this would be a really interesting alternative. It's like, instead of buying a lamp, because these aren't that expensive, how much was this one? It starts at £1.90 for the small one with the little blades, and it goes up to £2, £3 say, for the big one. And if you consider that's about $4.50 for American dollars, it's not that expensive. But let's crack this open, shall we? These magnets, yeah, I'm not sure I'd trust them to hold it inside a fitting. So how's this going to come out? Is it going to come out easily? It's a shame it's not available in warm white as well. That would have been nicer. Well, for people in hotter climates, colder climates, should I say. There's that thing that, you know, the colour temperature, the people in the warm countries like the cold white, and people in cold countries like warm white. Okay. So, it's not a transformer because it's not got enough windings on it. It just looks like a little choke. There's just two capacitors on top. I think we're going to have to explore this a little bit further. Hopefully it's got a suitable discharge circuit for the capacitor. I think I'll short that out shortly before I go any further, just in case it hasn't. These in colour, if they were isolated, mounted on a wall would be quite nice. Okay, there's a little clip here. There we go. Let's short that capacitor out, shall we? Yeah, it's dead. Oh god, there's not a lot of circuitry in the back, is there? So we get two capacitors and a choke in the front, and all I can see here is a transistor. There's not really a lot, is there? So that's going to be an active component then, isn't it, that little transistor type thing? It says 9918C. Right, I'm going to have to investigate this. I think we'll reverse engineer this. So I'll just pause momentarily and I'm going to see if I can find the data sheet for that. Okay, that took me a while because the data sheet, it was quite hard to find out just the 991A to C. But it turns out it's our old friends at Bright Power. It's one of their chips, and that little transistor is a full-on switching buck regulator. And here's what actually happens in it, from what I can make out. I'm not a super expert in the buck regulators, but the chip itself has, it breaks down into a couple of sections. It's got the power supply that it's taking current from the drain, which is the switching connection, with reference to VCC, which is its ground connection. Yes, it is its ground connection. So it's deriving its internal power from that. Then it's got this. It's got the control circuitry and a MOSFET inside for doing the switching, plus the CS point here is actually the current sense, and that's where the current flows through the MOSFET and then through the resistor down to the ground. Or in this case, it's to the negative rail from a bridge rectifier. And there's an op-amp here, which has a comparator, which has a built-in threshold of 0.6 volts. And that means that if you choose the resistor there, then theoretically, whatever the resistor you choose, you can set the current that's going to flow through that. In this case, if there's 3.3 ohms, which, let's see, I equals V over R, so that's 0.6 is the reference voltage, divided by 3.3 equals, so technically speaking that should be about 180 milliamps, but there's more to it than just saying that, because it's driven in a series of pulses, so it's much less than that, and that certainly is what the case is here. It was about 86 milliamps we got, wasn't it? Which was about half that, so that sort of alludes to a 50% sort of ratio. But anyway, the main differences to the circuit from the sort of manufacturer's sort of recommended circuit is that they've added a 200k resistor, and I'm guessing that's really just to discharge this capacitor here, this small capacitor. So what we've got here, we've got the rectifier come in, it immediately gets smoothed by this 6.8 microfarad 400 volt capacitor, which is this big one. Then that the positive end of that feeds it goes straight to the smaller capacitor, which is 3.3 microfarad at 250 volt, and also the end of the LED string. And the LED strings are it goes out here and then it just loops around these. So if you pulled one of those sections out, it would basically, all the others would go out too, because they are all in series. And they've put the 200k resistor across that, presumably just to discharge this capacitor. And there's a sort of, now this is apparently called a flywheel circuit. And what happens is that initially the MOSFET turns on and current starts flowing through the LEDs and through the inductor, but because it's an inductor and it has to sort of build up the magnetic field initially, there's an initial back EMF as it creates the magnetic field. Instead of just the current surging up to full, it sort of ramps really quickly, but still slow enough that the electronics can actually detect the current flowing and control it. So as soon as the current reaches through that, it reaches the threshold that's been set by this resistor down here to the point that 0.6 volts appears in the current sense, it turns off. And when it turns off, the charge is then sort of dumped out, but actually goes through this diode as far as I can make out, and charges the capacitor. So at each half of the cycle, initially the inductor being charged, and then it discharges, magnetic field collapses, seems to go towards powering the LEDs, which I suppose results in high efficiency. It's a minimalist circuit. It's really very, very simple. This little capacitor here is the VCC capacitor. It's the sort of it's just a smoothing capacitor for the internal circuitry in that chip, because let's face it, it's absolutely minute. There's not much there to actually incorporate things like a small level of capacitance in it. So it's got its own little capacitor, which I tried measuring it in circuit, which isn't always the best way to do it, and it came out round about 1 microfarad. It's a little multi-layer ceramic capacitor. So yeah, it's neat. It's a really unusual approach, but keep in mind that because the mains is coming through, going straight through a diode and then to the LEDs, and it doesn't matter which leg, it's going straight to the LEDs, and if you were to touch any of the metal connections, you'd basically have a reference, you know, to the mains. So unfortunately that means you can't, I suppose you could have this screwed onto a wall if it was well out of reach and you had a big sign next to it saying electrocution hazard. But other than that, you know, if you do get one of these and you play about with it, just keep in mind that all these LEDs potentially have live metal, and if you touch it and you were grounded at the same time, you could get a significant shock. It's worth mentioning that because it would just take all the fun out of it, really. So I'm just about to put these back together and play about with them again because I have really taken a shine to these. In fact, I took such a shine to them that I've actually ordered one of each type, so I've got a complete set of boards for no good reason at all. So yes, that's nice. So I'm just going to have a wee play and yeah, I like these just because they're so neat. But as I say, you'd really probably have to put them inside an enclosure. That said, it's quite a nice solution to putting lights into a large round fixture in the ceiling. It means that, you know, it can be fitted into a small box and then you just assemble it and suddenly you've got a large LED light source. So yeah, I like that. Really smart. A couple of little extra bits. My apologies to the Americans because it does in the front. It says 175 volt to 265 volts. So this is very clearly designed sort of for the Chinese markets, which is 220 volts, and it covers the UK market. But it means that if your voltage is just 110 volts, then there's a good chance this isn't going to work. All I can really think of doing there, I suppose it would work at the lower voltage if you had a smaller number of LEDs. Let's see, what would it be with just the, let's see, 1, 2, 3, 9 volts in each of these. 8 times 9 equals 72 volts. There's a possibility, and I can't guarantee it, but there's a possibility that if you choose one of the smaller ones that's rated with just what is it? It was rated at 12 watts, the one that just uses the 3 LEDs per section, then that may actually work on the lower voltage. But for the ones with the longer strips LEDs, the combined voltage is so high that ultimately it needs that the full wave rectified and smooth mains is high enough to actually light those LEDs in series. Another thing worth mentioning, if you do open yours up, there are these little end stops in here. The screws that hold the circuit board, the screw mounts that hold the circuit board down, are part of the thing that will stop the circuit boards going in. They've got sort of, you know, limits to actually stop them going in too far. And the other things, these little sort of plastic sort of sticky up bits to actually limit how far it can travel in. If you do open yours up though, note that when you put the circuit board back in, it's fairly symmetrical, the circuit board, but you've got the wires coming off one side. And the best place to actually put them out, I put a dot in mine after I'd disassembled it and then had to take the other one apart to see where the actual thing went out, because there is a little, there's a little indent for the cable to leave in the side here. And to make sure that the cables come out easily in the correct direction, it has to be, if you've got the screw holes here, it's 1, 2 down the second slot down, and put a wee dot there and aim the cables towards that when you put it back in, and that should align properly for the exit for the cable mounting. But yes, other than that, other than the slight fact that it's only suited to the higher voltages, well certainly in the higher wattages with the more LEDs in the series, other than that, I quite like these. I do like these a lot. These are quite nice. This is one I just decided to make with alternate long and short strips LEDs. Very smart indeed.